Hi folks, today we're going to introduce systems of equations and how they're used in everyday life. So let's get started. So Danny Say's Bakery boasts about making the best biscuits in Savannah, but with a boom in business, what can happen sometimes is you might occasionally run out of ingredients because you have more clientele. And so let's assume they run out of baking powder one day. Luckily, there's another way to make baking powder, and it's by using baking soda and cream of tartar. And you can mix those two ingredients together to get baking powder, but there's some sort of things you need. So let's say they need 63 ounces worth of baking powder on a given day where they ran out. And the ratio calls for 1 part baking soda for every 2 parts cream of tartar. Is it possible for the bakery to actually make baking powder and meet those needs of the kitchen that day? Well, we'll find out an answer here in just a little bit, but we'll make a small detour in the process. And what we're going to go to is actually lines and finding the intersection of lines. So we'll begin with, is it possible for us to find the intersection of the two lines y equals 1 minus x and y equals 1/3 x minus 3? So taking a look at the graphs of those two, we have y equals 1 minus x drawn in blue here, and y equals 1/3 x minus 3 drawn in red, and we're looking for where those two lines cross. And we can see that it occurs at that point 3, -2, and we've highlighted that with the black dot there. And so, keeping that in mind, well, is it possible for us to verify? I mean, seeing it happen on two graphs doesn't mean that's exactly right, because sometimes our graphs can be drawn incorrectly just a bit. And so we want to account for that. And so is it possible for us to verify, given that those are our two lines, that that's in fact that 3, -2 is that intersection point? And so keeping that in mind, we actually look at a system of equations. And what a system of equations is just a set of 2 or more equations using the same set of variables. And we find solutions to those systems of equations as being the set of values such that plugging in those values for those variables result in all the equations being true. So now we're just dealing with 2, but this can actually extend for more variables and more equations, just an FYI. Well, with that in mind, our question is, what is the solution to the following system of equations? You see this curly brackets on the left-hand side, and this y equals 1 minus x on top, and this y equals 1/3 x minus 3 on bottom. Those are our two equations. Our two unknowns or two variables are just x and y. So that's an equivalent way of looking at this problem, is solving this system of equations. Keeping that in mind, we'll actually label them equation 1 and equation 2 just for reference's sake. And now let's see if we can verify that 3, -2 is in fact the solution. So that means 3, -2 needs to be on both of these lines, or make both of these equations true. So we'll begin with equation 1, and we want to plug in x equals 3 and y equals -2. Since we're considering that ordered pair 3, -2, we want to plug that into equation 1. And when we do that, we get -2 equals 1 minus 3. Well, we can immediately see that this is actually true because you get -2 equals -2. Both sides are equal. So 3, -2 is in fact a solution to equation 1. Moving forward from there, we plug in x equals 3 and y equals -2 into equation 2 this time around. And what we have is -2 equals 1/3 3 minus 3. And in fact, this shows that we have -2 equals -2 once again. So 3, -2 is a solution to equation 2. So since 3, -2, that ordered pair, is a solution to both equations, that means we have a solution to the system of equations. So in fact, that is the intersection point. There's no ifs, ands, or buts about it. So systems of equations, solving for those, you're also finding intersection points on the graphs if we can draw a nice graph. So keeping that in mind, let's refer back to the bakery problem. So we had 63 ounces worth of baking powder needed to be created, while we're using baking soda and cream of tartar to create that. And we need 1 part baking soda for every 2 parts of cream tartar. Is it possible for us to find this? Well, here's how we go about doing that. We're going to begin by letting x denote that amount of baking soda in ounces, and y the amount of cream of tartar in ounces added to the mixture. So there's 2 conditions, essentially, that we need to look at. In those 2 conditions, we'll begin with the first one. It appears right in that first line. We have 63 ounces worth of baking powder. And remember, baking powder is created by mixing baking soda and cream of tartar. So that means if we add the amount of baking soda with the amount of cream of tartar, that should give us 63. So the sum of those two values, x and y, should give us 63. And the second piece, 1 part baking soda for every 2 parts cream or tartar. So think of it this way. If we have 1 part baking soda, we have 2 parts cream tartar. If we have 3 parts baking soda, that means we would need 6 parts cream of tartar. So the equation that corresponds to this is actually 2x equals y. I know this seems kind of counterintuitive, but notice if we take the x amount, we need to double it in order to get what the y value is every time. So that gives us our 2 equations, and our system of equations looks like 63 equals x plus y, or you can switch that around, x plus y equals 63. It doesn't matter which side of the equal sign that it's on, and y equals 2x. Those are our 2 equations right there. And can we solve this? Well, remember, we can actually look at the intersection. Hopefully we'll find out some better methods later on, but finding out the intersection, we can take a look at our 2 lines. So we get x plus y equals 63. It's in the red right there, that red line. And then y equals 2x is the blue line, and we're looking for where that black dot occurs. Well, if we draw a line up from the x-axis to where that occurs, we can figure out the x value. And so the x value looks approximately to be 21, since each of those tick marks are worth 1. And on the y-axis, a little bit trickier because this is going to be harder to draw that straight line across, but notice each tick mark is worth 2 because we're jumping from 40 to 50 and there's 5 tick marks in between there. So we end up getting approximately 42. So is 2142 actually a solution to this system of equations? Well, let's check it out. How can we go about doing this? First, we're plugging in x equals 21 and y equals 42 into equation 1. You get 63 equals 21 plus 42, or in other words, 63 equals 63, which means 2142 is a solution to equation 1. Now we just need to check, is it a solution to equation 2? Well, notice if we plug in for the x and y accordingly, you get 42 equals 2 times 21. And notice that gives us 42 equals 42. And so it satisfies equation 2. Therefore, 2142 is a solution to that system of equations. What does this mean at the end? Well, it means our baker's dilemma is solved. And in fact, the bakers should add actually 21 ounces of baking soda and 42 ounces of cream or tartar to the mixture to create that 63 ounces of baking powder. Just showing you how the systems of equations can come into play. And what we'll look for is better methods of solving these systems in time.